So in case you haven't heard of Node.js, Node.js is a wrapper around the V8 JavaScript engine provided by Google Chrome that allows you to run JavaScript outside the browser. In addition to this, it provides a bunch of other file and I/O functionality and fleshes out the standard JavaScript library a little bit further. One other part it did, though, is, as mentioned in the first video, introduced a module system called CommonJS. And additionally, it brought in a dependency manager and task runner called NPM. Now, even though we're not going to be writing any Node.js code, per se, we will be using Node.js to build, compile, and run tasks for our front-end React applications, and additionally to manage dependencies for it. So if you don't have Node, you can go to the official site and grab the latest version, go through and run the installer. Additionally, if you're on OS X, you can get it through Brew. As part of installing Node, you're going to get a JavaScript REPL. And you're also going to get a tool called NPM, which stands for Node Package Manager. Now, traditionally, we manage all of our JavaScript dependencies through script tags. And if we had to use any libraries, let's say we were in a basic project, we would have to create a directory called vendor. Then inside of vendor, we would download a copy of all of our different dependencies, jQuery.js, touch handlebars, and all of our different dependencies, or we'd use a CDN. But either way, inside of our actual HTML file, like so, where we want to use these dependencies, we would have to go script, source, vendor handlebars, and do the same thing for each and every one of our dependencies. And if our app involved multiple pages that needed these, it was a real pain. And we had to make sure to put R's after all of them since they depended on it. R.js file, which we don't have, but if we were to have one, right? And just not very maintainable. Not nearly as good as dependency management systems for most backend server-oriented languages, right? So what we'll do instead is we're going to use Node-style packaging, and then we're going to use Webpack to bundle this up. And what this looks like is instead of script tags, like we had before here, we're going to create a file called package.json, and we're not going to create it directly. We're going to create it through npm init, which is kind of like a git init. It's going to ask you different questions about your project. Most of them are fairly optional. If you're ever going to deploy this or do major things with it, you should fill it out properly. And the end result is going to be this package.json file, which is going to maintain a list of all of our dependencies. So instead of doing script source equals some CDN React, instead we're going to install it through npm by saying npm install save React. And then if we look inside of these node modules, we'll not only see React.js, but we'll also see React's dependencies. And additionally, it updated our package.json to contain React as a dependency. If you're working through Git or a similar version control system, typically you will turn in package.json to your Git repository, but not the node modules. The reason for this is twofold. One, node modules is derived information that we can figure out from the package.json. Two is while most node modules are just raw node JavaScript code, some of them have native components that need to be compiled. So if I were to commit a node modules that had stuff that was compiled on my OS X system, and you were to try to run it on a Linux system, you might run into problems. So the proper way to do things in most cases, there are exceptions, is to only commit package.json and to add node modules to your git ignore. The other thing that package.json could do for us is run tasks. So inside here, there's this little script section. We can add scripts here. It's kind of sort of like make, where we can define tasks such as build, go. Then if we go npm run build, it's going to run whatever bash command we specified there. So typically, instead of a trivial echo statement, that's going to poke Webpack to build our application, depending on how we execute it, either for development optimized setup or production optimized setup. So in this new system, There's a couple different ways you can manage your code. With raw node, we can use common.js, which looks like this. If we have script1.js and we have script2.js, we can write a function inside of script1, and then inside of script2, now if this was vanilla JavaScript and we were to run this through a browser as a script tag, it would do stuff in the global context, and then script2 would have access to it. And in order to prevent that in the browser, we'd have to wrap this up in Iffy or something equivalent, like so. But you don't have to do that in Node. And furthermore, when you bundle up your package through Webpack, you don't have to do that either. You can kind of think as if Webpack is doing all of the Iffies for you. That being said, if everything was always automatically in Iffy, you would need some sort of way to get things out of here. The way you do that with common.js is through module.exports. So here, if we wanted to export do stuff, we can say module.exports equals do stuff. Then inside a file that's interested in interacting with do stuff, we can say var do stuff is equal to require script1 and invoked. Then when we bring in do stuff into script2, we can run it like so. In addition to managing our own dependencies this way, we're also going to manage our install dependencies that way too. The difference being, instead of providing a local path here, we're just going to refer to it by name. So we can say var react equals require react. Notice the node dot there. That means we're going to check that little node modules directory. Take a look at the dependency. And see, here's all a bunch of different stuff from React. And we ran this through Node because, as we're going to explore a little bit later, React actually has two different packages now. It has React and React DOM. React is code that is shared between both React and React Native. And the implication of this is that it allows us to do server-side rendering with React. We can still create React components on Node on the server and then render them later with React DOM. We're not going to be doing that in this course per se, but it's something that can be done. And while I currently just showed you common JS syntax, we're going to be using ES6 module syntax, which is compatible. It'll compile down to common JS as part of our Webpack process. But one more feature that we have in ES6 modules as well in common JS modules is instead of a named export with one thing like this, we could export multiple things by name like this. Another function. Then this time I'm going to say exports.doStuff is equal to doStuff. Not module.exports equals, but exports dot. And exports.otherStuff is equal to otherStuff. And inside of here, I can say var doStuff equals require script1 dot do stuff. That'll just bring one of them, or if we want to bring in the other one, we can say other stuff, like so, and then use it like before. We're not going to be using that syntax while we could. In React, we're going to be using an equivalent ES6 module syntax. It's important to know about some of the details of this because this is what it compiles down to. And what's going on is whenever you do an export, there is one object that is being exported from the file. That object can be given properties like we did over here, right? Where we set one property to do stuff, another to other stuff. And additionally, instead of setting properties on that export object, we could do what we did in the first example where we reassign that exports object to something else, such as a function or another object entirely, and then we're exporting one new thing, and that's kind of like a default export. It's a little bit more clear in ES6 syntax, so we're not going to dwell on this too much, but do know this is an underlying implementation detail of it.